So in the previous session, we were talking about the distributed consensus. We talked about the Paxos consensus algorithm. So in Paxos, that we have observed that there are the miners who can categorized into three types, either the candidate or the proposer, acceptor, or listener. Okay. The same way, the Raft consensus algorithm is also known as the distributed consensus algorithm. We'll try to explore this. So the motivation here is the consensus algorithm basically allows the collection of machines in the sense here the mining machines, to work as the coherent group to build a block. So we know how to build a block. There are the steps which we have discussed so far. So that can survive the failure of some of its members. It is because of the network failure or network delay or because of hardware problem or software problems. So very important role in building the fault tolerant distributed system. So from there we looked at this Paxos. So in Paxos, when we talked about the algorithm implementation, the consensus algorithm implementation, we found certain difficulties to understand, and to implement that one, it was a bit harder to implement. So then the alternative in permissioned blockchain technology is Raft, which was this particular consensus protocol was introduced in 2014. And this is much easier compared to the Paxos consensus algorithm. And there are several open source implementations are there, like the Ethereum machines, fabricated machines, okay, that we will discuss in the next session in detail about them. So what is the key point in Raft algorithm is the executing the smart contracts on the local machines. Okay, so that we call the replicated state machine. So in replicated state machines, these are the fundamental concept in the distributed systems. So that enable the fault tolerant services by replicating the computation across multiple servers while ensuring they all behave as one logical machine. So this is the key point here. Right? So here, let us try to discuss the detailed structure which can explain the suitable for the advancing in this particular course. So what is the replicated state machine? The replicated state machine is a distributed system model in which we find, suppose, so in which the multiple servers we also called as the replicas. So they maintain the identical copies of the states. And all replicas, they starting from the same initial state. It may be replica machine 1, replica machine 2, replica machine 3. So they all start from the same initial state, and all replicas, they execute the same sequence of commands. And therefore, all replicas reach the same final state. So these are the key points, right? These multiple servers, like server 1, server 2, server 3, are we call the replicated machines. Okay? So even if some replicas fail, suppose in these 3 servers or replicas, if anyone fails, the system continue to operate correctly. So what is the key idea here is, instead of backing up data periodically, we replicate the deterministic computation itself. So here the state machine model, this state machine model or replication model, the state machine is consists of the state, that data stored in the system, and the commands. Okay, so that are the inputs or the operations that modify these states, and the transition function that maps the current state and the command to generate the new state, and the output is the optional here, that is the result returned back to the client. So what is there in this client? If you observe, the client's job is they collect all the valid transactions. So all the valid transactions means any node in the network can initiate the transaction and broadcast the transaction into the network. And that transaction collected by the remaining peer nodes, and they try to validate that transaction. How do they validate? By verifying the signature. Once the transaction is validated, that transaction is given as an input to these servers in the state machine model. So suppose Z is equal to 6. Suppose there is a transaction where $6 is deposited by user Z, suppose. So then that is given to a server or the replicated state machine. So, and the same transaction is, the received by all the state machines. Then these transactions will be, processed or executed by the state machine. So here the consensus model means the transaction is validated by all the clients. So then in the state replicated machine, that particular command will be executed to store this transaction locally in the same order. So that is the log file. Okay. In the same order, and then the state machine executed locally, and once it is executed, the transaction is added to the local storage. And the result is returned to the client. Yeah, this new transaction is added. So in this case, the state machine model, the deterministic property is there. That is the crucial one. So to work correctly, the state machine must be deterministic. So given the same initial state and same command sequence, which we have, the command sequence which is added here, okay? So all replicas must produce exactly the same state and outputs. So that is deterministic. So why replicate state machines are required means the motivation here is, in distributed system that faces the server crashes, any one server may go to crash state because of hardware or software, or the network partition or Byzantine faults. So the replica state machine that provides the fault tolerance, high availability, and strong consistency here. So the core architecture of replicated state machines looks like this. So the flow here is the client sends a command and the system agrees on the global order of this command. So all replicas execute the command in the same order. The same order. So all replicates transition to the same new state, which you are finding here. Same new state. And the output is the returning back to this client. So the two fundamental requirement here is, one is agreement, that is the consensus in this state replication. One is the consensus, so that is the agreement. So that means all non-faulty replicas agree on which commands to execute and in what order. And the second one is deterministic execution, that is the sequential execution. Okay. The sequential execution. So together, these guarantees the state consistency. So the role of the consensus in replicated state machines is the most important challenging to solving the distributed consensus. So the common consensus algorithm is the Raft algorithm. So we'll try to discuss that Raft algorithm.